Okay, Algebra 2, this video lesson continues Chapter 8.4, and it picks up with example 5, which focuses on how to use inverse properties. As you get to know these properties, you'll find that they give you shortcuts and methods to solve and simplify some logarithmic functions and logarithmic expressions that are otherwise difficult to work with. It takes me a minute to get to what those inverse properties are, so let's get started. In the last video, we talked about this example 2, and you went ahead and did this. You were able to evaluate this expression, log base 3 of 81. And you realized that that has to equal something, equals x, for lack of a better term, the placeholder. But you realized that you needed to translate that expression and say it's really asking you 3 to what power gives you 81. Once you translated that in words, you were able to rewrite it algebraically, and this is essentially saying the same thing. 3 to what power equals 81. And once you saw that, you were able to realize that the power you needed was 4. So x is 4, so in other words, log base 3 of 81 is equal to 4. That's from the last video. Now let's look at a similar situation, but a little bit different. Log base 5 of 5 to the 8th power. Well, again, like on the left, that's going to be equal to x. So you're asking yourself, 5 to what power is going to give you 5 to the 8th? And you might realize in algebra, that's essentially saying 5 to the x is equal to 5 to the 8th. Once you see this, once you see that this parallel here, it probably jumps out at you. Oh, x has to be 8 then. That is the same as that because the bases are the same. And like on the left, that means the log base 5 of 5 to the 8th equals 8. But notice what happened here. This exponent ended up matching the result. That will always be true when the base and the base of the exponent you're taking the log of, these two things here, are matching. So let's look at some examples here. I just did this one. Well, similarly, log base 7 of 7 to the 4th power is going to be 4. And log base 3 of negative 22, well, I'll give you a second and then I'll show you. Not surprisingly, it's negative 22. Let's collect this and look at the pattern and say there's a general rule. If these match, the base and the base of the exponent in a thing you're taking the log of, if those things match, then that exponent is going to drop down and going to become your result. So in other words, the log of this whole thing simply becomes the same as whatever the exponent was. Now, getting at inverses, as I promised, we were going to talk about the properties of inverses. Well, these are inverses of each other. The first function, f, is equal to b to the x power. It's an exponential function. The second one is a logarithmic function, and it's the inverse of the other one. The function g says the log is equal to the log base b of x. You know, I probably shouldn't have called it g of x. I probably should have called it f prime of x to make it very clear that these two are inverses of each other. Before I go any farther, I want you to practice and make sure you can see what the inverses of each other are. So find the inverse of this f of x. I'll give you a second. And I hope you said it was the log base 3 of 5. Try another one really quickly. I hope you said that the inverse of that is the log base 2 of x. One more. This time putting x in the base instead of in the exponent. I hope that didn't confuse you. That simply means the log base x of 4. I'm sorry, that simply means the inverse is. Let's spin it around. We've always been trying in both f and h and k here. We've been starting with an exponential function. Let's instead start with a logarithmic function and see its inverse. Remember, inverses go either way. So the inverse of m is simply 3 to the 5th power. Function n, its inverse, is simply going to be 2 to the x power. And lastly, function p over here its inverse is going to be x to the fourth power. I hope all of that was straightforward. Now again, we said the general rule is if these match, then that log's result, its value, is simply going to be that exponent dropping down to ground level, as I often say. You also should remember from back when we first started talking about inverse functions a couple of months ago that any kind of inverse functions undo each other. That's still true when we talk about the fact that an exponential function and a logarithmic function are inverses of each other. They're still going to undo each other. Let's look at why. If we've got f of x on the left and g of x on the right, well, we can do a composition of functions just like we did back a couple of months ago. Let's put g on the outside this time and see what happens. So that's going to mean that we've got the log base b, instead of calling the log base b of x, it's the log base b of a wide set of parens that are a placeholder, and in here we're going to put f of x. Well, remember f of x is b of x, b to the x. So there it is, log base b of b to the x. Well, these parens are not really doing anything any longer. They're not protecting anything. Let's get rid of those. And now you see that this matches this rule that we have up here. And sure enough, the result is x. That's the inverse in action here. So go ahead and tell me. Evaluate that for me. Hit the pause button. When you're ready, I'm going to show you the result. Okay, I've already had you do this problem. You should have recognized it, and it turns out to be 4. But let's look at a more complicated example. I'll help you with this one. The base is no longer matching, the base of the log is no longer matching the base of this exponent here. How would we make use of this rule that I talked about here? What we need to do is get these guys to match. If we don't, then we don't have an easy time with this. Well, we can make them match. Remember, 9 is simply 3 squared. Now the bases match. The parens aren't doing anything to protect anything any longer. You can distribute that x through, or multiply the 2 times the x, I should say. And so what we've got is simply matching bases, log base 3 of 3 to the 2x power. And now we're going to apply the same rule that we had up here, and we're going to find that the end result turns out to be 2x. Here, try one yourself. Similar problem, hit the pause button. When you come back, I'll show you the answer. Okay, I'm going to assume that you did that. Here are the steps you should have worked through, but you should have ended up finding that the answer is 3x. If you're not getting that answer or aren't sure that you followed it exactly correctly, hit the pause button and study the steps. Come in with any questions you have. Otherwise, we're just going to move on to the next slide. Okay. I said before, let's put g on the outside first. Now let's try putting f on the outside. Well, if I put f on the outside in a composition of functions, then what I really have is b to the, remember, f on the outside, there it is, f is equal to b to the x power. Well, instead of calling it to the x power, I'm going to make that exponent a wide set of parens, and inside I'm going to put g, which is this statement here, or this expression here. And there it is, in there. Well, remember, they undo each other. They work in the same way, and if inverses truly are inverses, then it doesn't matter whether you put g on the outside or f on the inside. Your end result should be x. And sure enough, it is. And so what's going on here is whenever the base of an exponent, an exponential expression that has a log in its exponent, whenever this base matches the base of the log in the exponent, once again, x drops down to what I call ground level and becomes the result. Let's practice one. What is this going to turn out to be? Hit the pause button, and then I'll tell you what the answer is. Okay, the answer is 3. Now let's look at a more complicated example. I'll help you with this one. There isn't a clear match here because there's no base stated here for this log. In this case, you got to remind yourself, wait a minute, If it doesn't say what the base of the log is, it's always assumed to be 10. So sure enough, these do match. And 2 does drop out as the answer. Okay, that's it for the video lesson. Like I said, come in with any questions you have. I'll look forward to seeing you in class.